Hello, I'm Martin Looker from Silicon Labs. Welcome to another video in our Simplicity Studio 6 series. In this video, I'll show how to create projects in Simplicity Studio that include code that you can then adapt to create your own applications. I'll be staying in Simplicity Studio for this video and focusing on the creation and configuration of projects. The next video in this series will show how to work with and edit project code in the Visual Studio Code IDE. Just like the previous video, I'll be working with the feature-rich EFR32XG24 dev kit. The board includes a wide range of sensors and other devices on the board, making it a great board for prototyping. Those peripherals can be added to by making use of the quick connector to work with additional I2C breakout boards. And if you are looking to create battery-powered applications, there is a coin cell slot on the rear. Before we get into projects, I want to make sure the flash in my board is fully erased before beginning a new project. I have Simplicity Studio open and my board is connected. To erase the flash, I'm going to go to the Tools page. Then select Commander. This will open the Overview page, and if I click on the Open Tool button, it will then open the Simplicity Commander tool. Simplicity Commander provides a range of tools to work with a connected device via the debug interface, including erasing the flash. First, I need to connect to the board using the Select Kit drop-down. Selection is by ID. I only have one device connected at the moment, which makes it easy. If you are working with multiple devices, you can check device IDs in Simplicity Studio's Devices page. Back in Simplicity Commander, the kit page displays basic information about the board, while the device information page displays information about the chip or module. On the flash page, amongst other things, you can upload binary files and also use the Erase Chip button to erase the whole flash. Now that my flash is erased, I can simply close Simplicity Commander and return to Simplicity Studio. There are numerous ways to access relevant example projects. In the previous video, we used the Devices page to select our connected board and access and flash pre-built binaries by using demos. We can also access example projects from this page, which provide code for a single application. The third option, Solution Examples, packages together multiple projects into a single solution. These mostly provide a solution with an application project and its companion bootloader project, as you can see with these Matter solutions. If you are unsure of the difference, clicking this info link will pop up an explanation. Filters can be applied using the checkboxes down the left-hand side. This is useful if looking for examples using a particular technology, or even by keywords. Say if we wanted to find a specific example like this Matter dishwasher. When working from a device page like this, only projects relevant to the selected board are displayed. You can also access demos, example projects, and solution examples from the home page. You can view all projects for all devices by clicking the All Projects and Demos link. You can pre-filter to a particular wireless protocol by clicking the appropriate button, such as Bluetooth LE. From this interface, you can limit it to examples for a particular board by clicking the Select Device button. You can select a connected board from the top of the list, or virtual boards lower down. If you don't have a board connected, the search box allows you to narrow down the large list of potential virtual boards. But I want to work with the board I have connected, so I will select it here. Today, I only want to work with example projects, and I'm going to look for a Bluetooth example that also runs as System on Chip. As you can see, we have 42 example projects matching this filter. We have examples with and without real-time operating systems, including empty examples that provide just the bare minimum framework for a BLE application. If you're looking to completely build your application, this is the place to start. Then we also have examples for some of the common Bluetooth devices, like this health thermometer application. If you are creating such a device, choosing this example will give you a head start on development compared to starting from an empty project. Reading the description, this example uses an onboard temperature sensor, which is great as it removes the need to add an external sensor while I experiment. But before creating this project, I want to learn a bit more about what it offers by clicking the View Project Documentation link. Here we have information on how the project works and how to create it. We can also use the Simplicity Connect mobile app to view the data from the example. So that is an easy way to check the functionality. Further down, there are some troubleshooting tips. Reading the bootloader section, I can see that this application, in its default configuration, requires a bootloader, and I'll need to create one. Fortunately, it tells me that for an SoC project on Series 2, I need to create a project for this bootloader. So I'll copy its name to help me find that project later on. It also lets me know that if I use the demo version of this project, both the application and bootloader binaries will be flashed into the board when the Run button is clicked. That's good information to know, but I want to work with the code today by creating a project. I could flash the demo just to get the bootloader in place in my board before creating and working with the project. That's if I wanted to move more quickly. But to show you what is involved, I'll create the bootloader project as well during this video. There are also some important notes here recommending the use of the .hex or .s37 binaries to flash to the board, as these binary file types include address information within the binary. I'll keep that in mind when I flash binaries in the next video. Before I close this documentation, some example projects and demos make use of external hardware peripherals. If this is the case, you'll find information on what devices you need and how to connect them included in the project documentation. Okay, so this BLE thermometer seems to be a self-contained example using hardware already on my board. Plus, it works with our Simplicity Connect mobile app for ease of use. So I'll click the Create button to start creating the project. In the project configuration window, I can change some settings to the project. I can change the name, and here I'm going to prefix the project name with the board number that I can see in the device pane. I do this because many of our examples can run on multiple boards, and I may want to experiment with this example on a different board in the future. So, by doing this, it's obvious from the project name which board the project is for. I'll keep the default location, but you can change it here if required. Then, there are various ways that you can work with the source files. The first, Link to Sources, will use all source files from the location they are stored in our SDK. This will work, but if you change any files, you are changing them for all future uses. If you create the project for different devices in the future, you will pick up changes to the application or project source files. And if you change SDK files, that changes them for all projects that use that file. So it's not a good idea to use this option as it has wide-reaching consequences. The second and default option links to the SDK files but makes copies of the project sources. This is generally the best option to choose, as you can work on the application files in the project, which are the files you generally need to change, whilst leaving SDK files unchanged. But keep in mind, if you do change SDK files, that will affect all projects that depend on them. If you do intend to change SDK files, the Final Copy Contents option also makes copies of the SDK files in addition to the application files. You can then safely change SDK files, and those changes will only affect that project. Note that changing SDK files is not recommended, as you may break functionality. Only do this if you know what you're doing. You can also change these settings later after you've created the project. So, I'm going to stick with the default option, allowing me to safely adapt the application files, but link to the SDK files, as I have no intention of making changes to them. Finally, we have the Target IDE setting. I'll be working with a Simplicity Studio extension for Visual Studio Code, so I'll keep this default. But you can find options for other IDEs here. Now I'm happy with the settings, I'll click the Finish button to create the project. Once the project is created, the projects list is opened. This is where we can see the project and its files. The .slcp file, which controls the project, is also opened. We'll take a look at these in a moment, but first I want to create the bootloader example project. To do this, I'll return to the Examples and Demos window I already have open. Then I'll clear the filter checkboxes and search for the bootloader name I copied from the Thermometers project documentation. Next, I'll click the Create button, prefix the board number to the project name, and click the Finish button. I'll return to the project or .slcp file for the thermometer. If you close the .slcp file and want to return to it, you can open it by double-clicking either the project file itself or the top-level project folder in the Projects pane. It is also accessible from the Home page in the Recent Projects list and the Home tab of the Projects page. We can see both projects are part of a workspace in the Home tab and at the top of the Projects list. In the Overview tab of the project file, we can make changes to the board and part where compatible. You can also select a different SDK version if you have more than one installed, and also change the project generator that controls how the project is to be compiled. In this box, you can change the import mode that controls how application and SDK files are brought into the project. Finally, on the right, you'll find quick links to commonly used tools and files. Options are available for projects using the ellipse buttons, including opening the folder in your File Explorer. And you can manage workspaces with the ellipse button here. The Configuration Tools tab provides access to various tools you might want to use to alter your project. As this is a Bluetooth project, we have access to the GATT configurator, where you can configure the Bluetooth profiles, services, and characteristics that form the application. The Pin tool allows pins to be assigned to on-chip peripherals. Though working with software components on the Software Components tab can often provide a higher layer way to manipulate pin assignments, and it also includes driver functionality for things like UART. As an example, this thermometer application uses a software component to control the temperature sensor hardware, including assignment of pins, plus another software component that works with and configures the part of the Bluetooth GATT database that works with thermometer data. We'll look at configuration tools and software components in future videos. In this video, we have explored how to create and manipulate projects in Simplicity Studio. The next step is to use the Open in VS Code button on the project file to move over to Visual Studio Code. There, you can edit the code, compile, flash, and debug the application, and we'll show you how in the next video. Make sure to subscribe to the Silicon Labs YouTube channel to be notified when it's available. In the meantime, check out the links in the video description. There, you will find help on working with both Simplicity Studio 6 and its extension for Visual Studio Code. Thanks for watching.